In this lecture, we are going to discuss about binary to ASCII conversion in 8085 assembly language programming. Now, what is the binary to ASCII conversion? Is here now we are having binary number. Assume that one 5a is a binary number. Now the binary is converted into ASCII. Binary is represented in the form of hexadecimal form, right? So this is one digit, then this is another digit, 5a. Now here first what actually we have to do is we have to get the first digit 5a. How do you get the first digit? Is you have to do AND immediate with f0. So you are getting now that 50. Now you have to rotate right with 4 times. So you will get now 05. So we are separating the first digit. Right? Now in that digit, the corresponding ASCII value for that number 5 is 35 hexadecimal. Here for a number 0, 1, 2, 3 up to that 9, the corresponding ASCII value is 30, 31, 32, 33 and so on 39. So here we are having now the 05 is 35. Then how do you convert that one? As here this is the number you are getting now. Within that number, if you are adding 30 hexadecimal, you will get now 35. Similarly, for each digit, we are adding 30, the corresponding ASCII value we will get now. This is the logic for digit. If it is alphabet, so we are having now 5a. In that 5a, now you have to separate that one with 0f and immediate, then you will get now 0a. Now, because it's an alphabet, right? Now that alphabet, you have to add 37. If you are adding 37, you will get now a plus 7. A is 10, 10 plus 7, 17. Now the 17, in the 17 we are having 116 is there, the remaining is 1. So here we are having now 1, then this one, okay, carry 1. So you are getting now 41. 41 is the hexadecimal for 0a. The A digit. For A digit, we are getting now that corresponding ASCII value is 41. So if you are having now the letter is or the digit is alphabet, so A to F we will get now. A, B, C, D, E, F. Right? So we are getting now any one of that alphabet, you will get now that in the ASCII, in the hexadecimal. So A to F, you have to add 37. Now we will see that how do you write a program. Now the input is 5a. Input is 5a. Then the digit 5 you are getting now the corresponding ASCII is 35. Then for alphabet A you are getting now as 41. Right? Now how do you convert that one? So here we are passing the digit by digit. If you are passing 05 as a digit in A and then we are calling this subroutine. So this subroutine is for binary to ASCII conversion. P to A is a subroutine. First you have to do with AND immediate with 0f. Just we are separating the digit as 05. First digit part. Then you have to compare immediate with that this 05 in accumulator. So 05 minus 0a. Whether it is alphabet or digit, we will find now. 05 minus 0a, compare immediate with 0a, right? So 05 minus 0a, if it is a digit, then you will get now carry. If it is a digit, you will get now carry. Then if carry is there, you have to add 30 and return. Add 30 and return. So if it is a digit, then we are adding 30. You will get now the corresponding ASCII and return the routine. If suppose it's alphabet 0A, 0B, 0C, 0D, 0E, 0F. any one of that alphabet you will get now. Then you are subtracting this with A. You don't have a carry. No carry. No carry. If it is no carry, you have to do 07 is added along with 30 also added. So 37 is added. You will get now the corresponding letter. So 0A is the input and you will get now 07 one time and we are getting now that one as 1 and then we are adding 30. You will get now 41. So the 41 is hexadecimal. So that's an ASCII value. 41 is ASCII value for letter A. So it is returning now, right? So this is the subroutine. Now the subroutine is going to call with digit by digit. We can call it now. So you have to separate in that main program. You have to separate the main program. You have to separate the digits. Then how do you separate the digits? The main program we are having that input is in 4300. 4300 you are having that input 5A. So LXIH with 430 this address, then the 5A is going to place on accumulator. So 5A is placed on accumulator. Then the 5A is moving to B register and also we are having that value is in accumulator also. So 5A is there. The input is there in B register as well as A register. Now that A register is going to rotate right. Rotate right is here RRC. Then it will do that one as A5. So 5A is moving to here. A is moving to here. So we are having now the rotate 4 times. You are getting now that A5. A5, 4 times you are rotating the digits, then we are getting now this numbers, right? So what it is actually RRC, right? So this is 5 is 101 and A is 1010, right? This one is you are rotating now. This 0 is going to have now 00101101 one time. Then next time we are rotating now. That one is going to come now 001 and 0110 is that. Next time we are rotating now. That 0 is going to come now 0 100 then 101 then 1. You are getting now, right? Then next time we are rotating now. Then we are getting now here 10 0 101. So this is A. This is 5. So initially we are having now 5A. Now we are having rotate right. You will get now A5. So that one as the higher digit is going to come in the lower part and lower digit is going to have now in higher part. Just now, then we are calling now that binary to ASCII. Then binary to ASCII, what it will do now? It will take only lower digits. Binary to ASCII, it will take lower digits. So it will convert that one as you are sending now with A5. Then P to A is doing now intermediate with 0F. Then it will take now that one as 5. Right? Then this 5 is going to convert into the ASCII. So you are getting now the 35 in 35 in accumulator after returning that call. Then the 35 is going to be load in the increment H. H is 4301 0 then 4300. Now we are incrementing by 1 4301. In that 4301 we are storing now 35. So the lower we are having now 35 in the higher digits for 5, right? Then next we are what we are doing now. Then in that A we are having now that one 35. Then in that B we are having that 5A. This 5A is passed on to A. Then once again we are calling now. Now we are calling with 5A. Then it will do now intermediate with 0F in the routine. And then we are getting now this A0. Then for that A0, it will return 41 hexadecimal. Now the 41 hexadecimal is going to place in 4302. So increment H. Then we are getting now this one as increment H. This is 4302. In that location, now we are having now this 41 is a return. This 41 is going to move to. So now we are getting now the 41 in the ASCII value for letter A. Then here this is in 4301, 4301. This is in 4302. In that 430 we are having now 5A. 4300 the input is 5A. So that one is converted into binary to ASCII. Okay, we can stop here.